Hey folks, if you're watching this, you'll notice that the notes are already 100% done. Normally, I only do this if the notes are going to be very long. In this case, I don't think they are, but this is, for full disclosure, this is my third attempt at recording this video. I keep having issues with the app, so it's getting kind of frustrating, so I'm just working with it already written down because it's frustrating to have to write it down over and over again. So if you're watching this, that means, hey, it worked this time. So fingers crossed for me in this very moment. But let's get started. This is part 2 of the video series. Yeah. It's part 2 over factoring and solving polynomial equations. So I'm going to start off with a couple factoring and solving together. Now, on this one, it doesn't look like it's a difference of squares because it's to the 4th power, but in order to be a difference of squares, you need to have only 2 terms and a minus sign in between. So if those 2 terms have square roots, then you have a difference of squares. So when you take the square root of an exponent, you just cut it in half. So it's easy to cut 4 in half, that's 2. And then you take the square root of the coefficients like normal. So square root of 16x to the 4th is 4x squared, the square root of 81 is 9. And then the difference of squares pattern says you use those square roots, but make one plus and make one minus. And the thing with this one is you have the difference of squares again. How do I know that? Because there's a minus sign, there's 2 terms, and each of those 2 terms has a square root. 4x squared square rooted is 2x. 9 square rooted is 3. So I'm going to say 2x plus 3 and 2x minus 3. So this is boxed in because I'm done factoring, but if I'm going to solve, I want to know where it hits the x-axis. So each time you see an x, set it equal to 0. In this case, with the 4x squared plus 9, when you minus the 9 over and divide by the 4, well, you have a negative number. So remember, when you square root a negative number, you're left with an imaginary solution. But for this section, I'm not really interested in imaginary solutions. So you could say, yeah, x equals plus or minus 3 over 2i. But it does actually equal plus and minus 3 over 2. For real. The real solutions are right here because you're not square rooting any negative numbers. I can minus 3 over, and yeah, it's negative 3, but I'm not square rooting a negative number. So x is at negative 3 over 2, and then I add 3 over, and x is at positive 3 over 2. Okay, so that's all there is to the solving part. So looking at the one next to it, it's a pretty similar example. It's a difference of squares again because the square root of 625x to the 4th is 25x squared. The square root of 256 is 16. Make one plus, make one minus. That second one that's minus, check to see if that one's a difference of squares again. Does each term have a square root? Yes, it does. Square root of 25x squared is 5x, square root of 16 is 4. The reason why you just check the minus one is there's no sum of squares pattern, okay? There's a sum of cubes pattern and a difference of cubes pattern that I covered in the last video, but there is no sum of squares pattern, just a difference of squares, okay? And anyway, back to this. 5x plus 4 and then 5x minus 4. And then have this 25x squared plus 16. So you'd set each term, each binomial term equal to 0. And this one will end up having a negative square root because of the same reason before. I'm going to minus 16 and then I'll have to square root a negative. So I just put that explanation there. And then this one, 5x plus 4, well, I'm going to minus 4 over, divide by 5, and I get negative 4 over 5. This one I'd have to obviously add 4 over and then divide by 5, and I get a positive 4 over 5. So it's pretty much the same process. All right, so the next section is determining whether a linear binomial is a factor. And so we're going to use synthetic division, and the remainder must be a 0 in order for something to be considered a true factor, okay? So remember synthetic division, you just write the coefficients of your equation as long as it's counting down. The degrees are going down perfectly. It's going degree 2, degree 1, 0 degree. So you don't have to add any zeros for a placeholder on this one. If you want to see an example like that, see the synthetic division video on my channel. But and then remember, synthetic division is defined as dividing by x minus k, so k equals 2. And so you put the 2 on the outside, the coefficients 1, 2, and negative 4. On the inside, bring down that front number, and then multiply to the outside. So I get 2. Well, so I wrote the 2 there. What's 2 plus 2? 4. What's 4 times 2? Excuse me, 8. What's negative 4 plus 8? 4. So that remainder was not 0. So x minus 2 is not a factor. Okay? That's all there is to it. So on this one, I am going to show that x plus 3 is a factor. So I'm going to do the synthetic division thing right here. And then you'll see that the remainder is a 0. And then it says factor f of x completely. Okay, so this is what I mean. We're going to do the synthetic division part. You see that it skipped over an x squared, a 0x squared, because it went power of 4, power of 3, it skipped power of 2, and then it had power of 1, power of 0. So I added in that 0 right there. If you don't do that, you're going to get the wrong answer. So you're dividing by x plus 3, so k is negative 3. Bring down the front number, multiply to the outside. So you get negative 3 plus 3 is 0, times negative 3 is 0, plus 0 is 0, times negative 3 is 0, plus negative 1 is negative 1. Negative 1 times negative 3 is positive 3. Added to negative 3 is 0. So remember, synthetic division, you get your powers going down by 1 because you're doing x to the 4th by an x term. So it'll start with x to the 3rd, then x squared, then x, then your constant term, then your remainder. So you see I have zeros for these, so I don't need to write that. So my quotient is x to the 3rd, like 1x to the 3rd, but you don't have to write the 1, right? Minus 1. And then since you're factoring out means what are you dividing it by? Put that on the outside. So I understand factoring with synthetic division might look weird, but we were dividing it by x plus 3. But we were using synthetic division to factor it, so don't forget to put that on the outside. So that's the only difference between factoring with synthetic division and then just regular old dividing with synthetic division. And yeah, I mentioned this earlier, but it was written down. The remainder is 0, so you know x plus 3 is a factor for sure. If it's not, then you wouldn't have to do this second part to write it in factored form. You would just put the explanation like I did up there. Okay, so let's move on to the rational root theorem. The rational root theorem basically is used to list the possible solutions for a polynomial equation, and then you could test those possible solutions using synthetic division to help you factor it out fully, okay? And that's, it's good for using when you have a polynomial equation that doesn't have any special patterns, per se. Like, I don't think you could do this by factoring by grouping, just looking at it at a glance. So yeah, that's basically what it's used for. So this is the formula. You're going to take the factors of the constant term, that's the last number, without any letters by it. Factor the leading coefficient, that's the coefficient by the letter with the highest power. And then you just divide. So you have to list all the factors of each number, though. So what I did on this one was my answers, my possible solutions, I'm going to use the factors of the last number, the constant term, 20, over the factors of the leading coefficient, that's 1. And so here are my factors of 1. It's 1 and 1. You notice I wrote plus or minus, because all your factors are plus or minus, because you could multiply 2 negatives times one another or 2 positives times one another. My factors are 20. I could do 20 times 1 or 10 times 2 or 5 times 4. So I just made fractions with all of them. These are commas right here. So I just went down the list, 20 over 1, 1 over 1, 10 over 1, 2 over 1, 5 over 1, 4 over 1. Obviously, those all make whole numbers, so you could have just said 21, 4, 10, 2, and 5. Make sure you throw plus or minuses by them. And that's it. So at this point, you'd use, you test a possible solution. You go down the list testing the possible solution, starting with 20 or negative 20, doing synthetic division. And if you got a remainder of 0, then you could go ahead and factor it out from there. But we're not going to do that. We're just going to go over what the rational root theorem is and list the possible solutions. So on this last example here, it's real tempting to say, oh, 60 is a constant term because it comes last. No, there's no constant term. It's missing because it needs to be without an x, all right? So the leading coefficient's -4. So if you do all the 60 stuff, you're going to be writing a whole lot. And so when I did it initially, I was like, oh, it's all this. And then as soon as I finished it, I was like, oh, wait, the constant term was 0. So it's good that I made that mistake because now I get to point it out. So that's why it's all marked out. The possible solution using the rational root theorem is 0. So I divide by x plus 0, or in this case, I divide out an x squared plus 0 because you can see that they all have a common x squared. And then I would test that and factor the rest out using synthetic division. And yeah, that's pretty much it. So it's pretty easy if there's no constant term because 0 divided by any of these numbers is still going to be 0. So yeah, that's it for the notes. Thanks for watching. Stay tuned for additional videos. All right, bye.